What's up, Fortnite gamers? Mr. Cully coming at you, and today I want to talk to you about a pretty advanced form of covalent bonding, which kind of dives into something called organic chemistry. And organic chemistry sounds really scary, but I'm going to try to simplify it as much as possible because it's just chemistry class, and I'm not trying to teach like a professor. But organic chemistry, when you hear the word organic, you probably think of something like life, like plants, or something you've heard of organic before, organic foods, and organic is just a fancy word kind of for life. So organic chemistry deals with the chemicals or the elements of life, which usually are made of the elements carbon and oxygen and hydrogen and nitrogen. Those are the main elements that we're dealing with. And so those are all nonmetals, and the way that they bond with each other is covalently bonding, which means they're sharing electrons. So what we're going to be drawing here over the next couple minutes is several covalent compounds, which are actually compounds of life in organic chemistry. So the first one right here is C2H6. And the way that I go about this first is I look at my compound and I say, okay, what are my main elements? And what I mean by that is the main elements are the ones that form a lot of bonds. So carbon is really good at forming bonds. Why? Because it has 4 valence electrons that all need a buddy. Hydrogen only has 1 valence electron, so it's not really good at forming bonds. So I usually save hydrogen for last. So in this compound, we have C2H6, which means I've got 2 carbon and 6 hydrogen. So what I'm going to do first is I'm going to draw my 2 carbon first. So I'm going to draw my 2 carbon first, just like this. And I'm going to draw my valence electrons around them. So there's 4 valence electrons around carbon, each of these. And I know I have 6 hydrogen. Okay, so I have 6 hydrogen and I need to put them somewhere. So I have 6 hydrogen that each of them are going to have a valence electron. And so I'm just going to draw on my 6, kind of like this. And I need them to bond together to make this whole thing one nice big molecule. And so we see that we have a lot of lone buddies out there. Every single one of these doesn't have a buddy to them. So I need to figure out a way to share these with each other so that it's going to work. So looking at it right now, I can actually see like it's already kind of paired up kind of nicely the way that I drew it. So these guys could share right here. This guy could share with the bottom one down there. The top guy could share with the top guy right there. And honestly, I could probably do the same thing over here with the other carbon. I can attach 3 of the hydrogen to that carbon as well, just like that. So those lines represent sharing. And, well, what's left is I could actually connect these 2 carbon just like that. And bada bang, bada boom, I've used both my carbon and I've used all 6 hydrogen and I made this molecule. So really, the way that I do it is I draw the 2 carbon first because those are the main guys. I draw out my 6 hydrogen, and you just got to connect the dots so that everyone's got a buddy and everyone's happy. And so once you do that, if everything's allotted, there's no buddy left behind, everyone's paired up, you're done. You've done your molecule, okay? Let's compare this to C2H4. So C2H4 is a similar molecule. It's got 2 carbon, but this time it's got 4 hydrogen. Okay, well, let's draw my 2 carbon again first. And each of those has 4 valence electrons. Okay? But this time, I only have 4 hydrogen. And so the question is, how am I going to do this time? It looks like I've got too many buddies and 2 less hydrogen. So how's this going to work? Well, let's go ahead. Let's bond our hydrogen to the carbon, kind of like we did before. And let's ask ourselves, what can we do here? Well, each carbon is left with 2 unpaired sides. So just like before, I could connect these guys, and I am allowed to connect these guys too. So these guys down here are allowed to connect together. What this makes is called a double bond. That just means like there's 2 bonds between each carbon, and it just forms a stronger bond essentially between them. So this works too. So sometimes you're going to make double bonds or triple bonds, never quadruple bond. But there might be several bonds between the same 2 elements, okay? And that's allowed. So here we have 2 carbon, and there's 2 hydrogen on each of them. So it works out. So the compound C2H4 would look like that, all right? Let's ramp it up a little bit. We have a little bit longer looking one, and right here it's called CH3CH2OH. This is actually called ethanol, which is what you put in cars. It's also in your alcoholic beverages. And so what you look at here, what you look for is your main guys again. Your things, I can't talk. Forgive me. Besides hydrogen. So your main guys are going to be carbon and oxygen. So I'm going to kind of draw it like a chain. I'm going to draw it each of those in that order. So I have a carbon, and an oxygen. Then you draw your valence electrons around them, like so. Each carbon's got 4. Carbon always has 4. And oxygen's got 6. So that means that 2 of the sides on oxygen already are buddied up. They're good. They don't want to bond with anything. But we see that 2 of them are lonely, and they do want to bond, okay? When you have a chain like this, you can go ahead and connect them like this, like they're in a chain, okay? And then you might ask yourself, okay, looking at this formula, why is it that they broke up the carbon and the hydrogen? Why wouldn't they just write, C2, and it looks like I've got a total of 6 hydrogen. Why didn't they just write it like C2H6O? Well, the way that they wrote it here is actually giving you a hint to how it's all going to bond together. I'm glitching out. It's okay. It's all right. Everything's fine. And what do I mean by that? Well, the fact that this says CH3, the hydrogen coming after that carbon actually mean that those 3 hydrogen will be bonded to that specific carbon. So this first carbon is going to have 3 hydrogen bonded to it. Well, let's look at that first carbon. This works out really well because that first carbon has 3 spots to fill. So I could draw my 3 hydrogen around that carbon like so, and then bond them just like this. Okay, so now that carbon's got the 3 hydrogen attached to it. All right, cool. Well, what about here? It says CH3, then CH2. Well, that means that there's 2 hydrogen bonded to that carbon. Okay, well, let's see. Let's look at it. Okay, that works out really well because I have 2 spots that I could bond that hydrogen to. All right, that works out really well. And then lastly, I've got this oxygen, and it says that there's a hydrogen bonded to that oxygen. Well, that works out because there's only 1 space to bond to on that oxygen, and now it looks like it worked out pretty well, and it does. So the way that the formula is written actually helps you out in the end sometimes with how to bond it. So the tube that we did before this didn't really help you out. The longer these chains get, the easier that it is to kind of see where these hydrogens go. All right, so looking at this, the formula gives you a hint to where these where these hydrogen go. All right, let's do one more. And this one, it looks like a doozy. Let's take a look. So again, when you get a long one like this, what you're going to do is you're going to underline or just kind of point out your main guys, your guys that are not hydrogen. All right, and so I'm going to put all these in a chain. So it looks like I have a C, I have an N, I have a C, I have an O, a C, and an O. Okay, next step, I'm going to draw out all my valence electrons. So carbon's got 4, nitrogen has 5. Okay, so that means it has 1 side with 2 on it, which means it's good. Carbon's got 4 again. Oxygen has 6, so it's going to have 2 sides that need a buddy. And carbon has 4 again. And then lastly, we got this oxygen down here. Okay, all right, and again, it's like a chain, so I'm going to connect them all, make this chain. And then, if you remember, the next thing that we do is we look at the formula for a hint, okay? Well, it's CH3 to start out, which means I have 3 hydrogen bonded to that carbon. Good. That's going to make this easy because there's already 3 spots there for those hydrogen to go to. Good. All right, next one. It says NH. That means that there is 1 hydrogen bonded to that nitrogen. And that's great because I only have 1 spot there. Next one, CH2. That means I have 2 hydrogen bonded to that carbon. Well, that's also great because that means, or looking at that, I've got those 2 spots to fill. Those 2 hydrogen fit on there perfectly. Okay. The next one is oxygen, and it doesn't have anything after that except for that carbon it's connected to, which means there's probably no other things to bond to it. And that's correct because this oxygen already has a double at the top and a double at the bottom, which means they're good. They don't want to bond with anything. Then I have carbon, and I have a CH. That H means that there's a hydrogen bonded to that carbon. Okay, so I have 1 hydrogen bonded to that carbon, and then it gets a little confusing because there's no hydrogen left. So If there's no hydrogen left, that's a problem because I have a lonely buddy down here and a lonely buddy over here. And so that means that I'm going to do what I did before, and I'm going to have to make a double bond. So there's two ways you can do this. You could just draw a line and curl it around like that to share those two. That's totally fine. Or if you want to clean this up a little bit, you can make it so that your double side on oxygen is on the right side and your lonely side is up top. And then you can connect it like that to make it look a little cleaner. And that's what I like to do. So this is kind of the process that you do it. This is the very first thing that you do with organic chemistry is you kind of make these long chains with carbons and nitrogens and oxygens, and they form these organic molecules. The way you go about it is you start with your main guys, your carbons, nitrogens, and oxygens, okay? Then after that, you look at the formula for any clues to tell you where you're going to put your remaining hydrogen, okay? So you kind of branch off your hydrogen for each of those. And then when you're done with that, that's where you have to ask yourself, okay, if there's any left over, that means I'm going to have to put some double or triple bonds in, depending on how many of those lonely guys are left, all right? So this is the basis of how you do it. This is kind of the steps that I take, and these are going to help you. These examples will help you with your worksheets too.